Okay, so in this particular case, we've got oxygen reacting with FeS. So that's iron 2 sulfide, and it produces iron 3 oxide and sulfur dioxide. And we need to calculate the volume occupied by the sulfur dioxide at room temperature and pressure. Right, so the first thing I'm going to want to try and do is work out the number of moles of sulfur dioxide actually produced. Right, but in order to do that, I would need to first work out the number of moles of oxygen that reacts, right? Because if you look at the way the question is worded, oxygen is the limiting reagent, right? So I'm going to work on figuring that out first, right? So so for oxygen, the relevant equation in this case would be that the number of moles N is equal to the mass M in grams divided by the molar mass, right? MR in grams per mole. So we've got the mass. So we've got the mass is it's going to be 9.02. So this is all, just to clarify, this is all for oxygen, right? That's in grams. The relative, the molar mass. I mean, we've got the relative atomic mass of oxygen. If we look at the periodic table, oxygen's here. We've got 16. So 16 is O2. So it's going to be MR of O2 would be 16 times 2, right? Which is going to be 32, right? Grams per mole. All right. And so that's going to be 32. And in terms of the, so from that point, working out what N is, that's simply going to be, therefore, N is equal to, so these, you just plug in those numbers, so 9.02 divided by 32. So that's, let me just clarify again, that's the number of moles of oxygen specifically. So that's going to be, well, if you work that out, you should find you get 0.281875, and that's going to be in moles, right? So we have the number of moles now of the oxygen, but what we're actually looking for is the number of moles of the sulfur dioxide. And if we look at the molar ratio in the balance equation and try and articulate that, so the number of moles of oxygen compared to the number of moles of sulfur dioxide, for oxygen we've got 7 here, so it's going to be 7 to 4, right? What does this tell us? This tells us that for every 7 moles of O2, we're going to have 4 moles of SO2 produced, in this particular reaction, given that oxygen is the limiting reagent specifically. If we want to get 1 on this side, we're going to have to divide both sides by 7. So if we do that, so we can say therefore, for every 1 mole of oxygen, we're going to have 4 over 7 moles of SO2. So therefore, the number of moles of SO2 is equal to 4 over 7 multiplied by the number of moles of oxygen, right? And we have the number of moles of oxygen, so we can therefore say that therefore, I mean, you don't need to write this part out again, just write equals 4 over 7 multiplied by, and this is the value I'm referring to, this is the moles of oxygen, right? So that's going to be 0.281875, okay? And so, and that's going to give us it's going to give us 0.1610714, right? And that's going to be moles. So this is going to be our moles of SO2, right? But what the question asks us to work out is not simply just the amount of substance, but to work out the volume that the SO2 is going to occupy. And now the question also tells us that for every given mole of any gas, specifically at room temperature and pressure, the volume occupied is going to be 24 decimeters cubed. And so specifically for the amount of substance of SO2 that we have, if you multiply this number of moles by 24, we're going to be able to get the volume. So we can say that the volume of SO2 is going to be equal to 24 multiplied by 0.1610714, right? And that's going to give us, well, if you do have a go at working out what that is, you should be able to find that. And just to clarify, that is a 0. So, I mean, it looks a bit ambiguous currently. That is a 0. Yeah. But yeah, so anyway, if we do work that out, we should find is you get 3.8657136, right? And that's an 8, you know, and that's going to be in decimeters cubed, right? And well, we do need to get this down to 2 decimal places, right? So in order to get it to 2 decimal places, we simply need to round this. So I mean, in this case, we're going to need to round up, right? So it's going to be 3.87 decimeters cubed, right? And we can say that that's down to 2 decimal places. Okay,